Good morning, all of you. In this video, I would like to explain Coulomb's law. Let us start. According to Coulomb, if I have two charges having magnitude Q1 and Q2, for example, I have two charges having magnitude Q1 and Q2, and they are separated by a distance of R. So these two charges are separated by a distance R. And these two charges are assumed to be point charges. Okay, then according to Coulomb, there will be force of attraction or repulsion between the two charges Q1 and Q2, and the force of attraction or repulsion will be given by F is equal to K into Q1 Q2 by R squared. See, if you observe this expression, the force of attraction or repulsion is directly proportional to product of charges. F is directly proportional to Q1, Q2. Means what? If charge Q1 or Q2 is increasing, force also increases. If charge of Q1, Q2 decreases, force will also decrease. Now, the force is inversely proportional to square of the distance between the two charges. Means what? If the distance between the two charges increases, the force of attraction or repulsion will decrease. If the distance decreases, the force will increase. Okay. Now, the charges may be positive or negative. Let us assume that the charge of Q1 is positive. Charge of Q2 is also positive. Otherwise, I can take charge of Q1 as negative, charge of Q2 is also negative. Okay. Then there will be force of repulsion between the two charges. If two charges are like charges, then there will be force of repulsion. Okay. Now let us take the first charge Q1 is positive and Q2 is negative. Now let us assume Q2 as so Q1 is positive, Q2 is negative. Now I'll assume Q1 as negative and Q2 as positive. Now there will be force of attraction exist between these two charges. Okay. Now in which direction the force will be acting? For example, let us take the charge Q1 as positive, charge Q2 as negative. If one charge is positive and another charge is Q2 is negative, now there will be force of attraction between them. So for example, the force exerted by charge Q1 on Q2 will be in this direction. Means this charge Q2 will attract Q1. So in this direction. So the force will be in this direction. Similarly, the force exerted by Q1 on Q2 will be in this. So that's why there will be force of attraction between these two charges. Let me draw here. Okay. Now Let me take Q1, Q2 again. And this time I am taking both charges as negative. See, as both charges are negative, there will be force of repulsion between them. Then the force exerted by Q2 on Q1 will be this direction. And force exerted by Q1 on Q2 will be in. So the force is a vector quantity, but for this class we confine our attention only to scalar. Only we are considering magnitude in this video. Okay, now what is the value of this k? Now we'll see. The k will be given by 9 into 10 to the power of 9 Newton meter square per coulomb square. How did you got these units for this k? Just what you will do is you bring all the remaining things except k to the left side. Then k will become f into r square by q1 q2. So what are the units for force? Newtons. Unit for distance is meter, as it is r square will get meter square. Unit for charge is coulomb. Coulomb multiplied by coulomb will get coulomb square. That's why we got the units for k as Newton meter square per coulomb square. Later, for the convenience, the force equation is written like F is equal to 1 by 4 pi epsilon naught into Q1 Q2 pi r square, where epsilon naught will be permittivity of free space and the value of epsilon naught will be given by 8.854 into 10 to the power of minus 12. What are the units for this epsilon naught? See, just you bring remaining things this side except epsilon naught, then we will get units as coulomb square per Newton meter square. Otherwise, I can write this as coulomb square Newton power minus 1 or minus 2. So this is all about Coulomb's law in the scalar form. In the next video, we'll see Coulomb's law in vector form. Thank you all.